In this video, let us talk about the FindAll method to extract all the patterns matched in a given string or a line of text, the different regular expression character classes, and the sub method to substitute the string onto the matched pattern, and also to use different options of compile method to facilitate the programmer in specifying the regular expression while creating the regular expression objects. Finally, we will take up few programming examples and apply all these regular expression methods to solve the simple pattern matching problems. In addition to search method, the regular expression object has one more method called FindAll method. What is the difference between search and FindAll? The search method will return only the first matched pattern as a matched object, and it is a string. The FindAll method will return all the matched strings as a list. This is how the FindAll method can be used to match and return all the occurrences of a particular pattern as specified in the regular expression. Let us take up the example of search. Here we have two occurrences of a telephone number, but still the search will return only the first occurrence. If we write this as a first at this place, definitely this is returned with the group method. And instead of using search, if we use the FindAll will return all the occurrences of the pattern as a list. You can see this FindAll will return a list of strings which obeys the pattern as specified in the regular expression. If there are groups present in a regular expression, then FindAll will return a list of tuples where each tuple represent the group, that is a matched groups, and the return is a list of tuples. Let us take up the example. We have three groups here. Group 1 is an area code, and this is the first portion of the telephone number, and this is the second portion. And if we use the FindAll method will return a list of matched strings. We have two strings and we get two lists, and each list is a tuple containing the groups. You can see here, this is the list, and we have a list of tuples. First tuple containing three matched groups. This is the first group, second group, and third group, and this is the second item in the list, second tuple representing the second number with three different groups. To summarize what FindAll method returns, remember the following. When it is called on regular expression with no groups, method FindAll will return list of strings which the regular expression matches. And when the FindAll method is called on regular expression having groups, then FindAll will return list of tuples where each tuple represent the number of the matched groups within the matched regular expression. Here we have a list of regular expression character classes. D is for any numeric digit, D is any character that is not a numeric digit, W any letter, numeric digit or underscore character, and capital W any character that is not a letter, not a digit, not underscore, and S is space, tab or new line, and capital S any character that is not a space, not a tab or new line. Remember, these character classes are very useful to shorten the irregular expression. For example, if you use the character class like this 0 to 5, 0 hyphen 5 with the square bracket, it will match to a numbers 0 or 1 or 5, and this can be even represented with the pipe 0 or 1 or 2, etc. This is how one can use these character classes to shorten the length of the irregular expression. Creating our own character classes. Suppose we don't want to match a set of characters with the shorthand character classes, then we can create our own character class using the square brackets, and we have to specify all these characters belongs to this newly created character class within the square brackets. Let us take up the example of creating a vowel character class. And how we are going to create this vowel character class? We have to enclose all these vowels A, E, I, O, U capitals within the square bracket, and now we can retrieve all the occurrences of vowels present in a given line of text with the method FindAll. FindAll will return a list of matched characters vowel present in the given line of text. This is the result of this. You can also include the ranges within the character classes by using a hyphen. And for example, we can, if you want to have a alphanumeric matching, then you can specify A to Z, capital A to Z, and 0 to 9, which matches to all the lowercase characters, uppercase characters, and even numbers. And remember, inside square brackets, the normal regular expression symbols are not interpreted as such. It means that if you use a star inside the square bracket, it doesn't mean that 0 or more, or if you use a plus, it doesn't mean that 1 or more occurrence. And in that case, with that, you don't have to escape the default behavior of slash. Remember, this is only applies if you are enclosing these irregular expression symbols or characters within the square brackets. You don't have to escape the default behavior, because these are considered as the characters of the newly created regular expression character class. As an illustration, let's take up the character class 0, hyphen, 5 and dot. It matches all the digits 0 to 5 and even the dot period, and we don't have to use a slash dot to escape the default behavior, as it is considered as one of the character in the newly created character class. And by placing the character, we can even create the negative character class. And what is this negative character class? Negative character class will match all the characters that are not present in the given newly created character class. Let's take up, suppose we want to create a consonant class. What we have to do, we cannot write all the consonant as in the regular expression, because it's more than 15 characters, and it's really hard to type all those things. What we have to do is, we can create a regular expression, we can create a vowel character class, and then we create a negative character class by using a caret symbol. This is a vowel character class, and then we use a caret symbol as a prefix, the first character in the newly created character class. It matches to all the characters which are not present in this, and ultimately it matches all the characters which are vowels, or even which are consonants or even spaces, dot, etc. And if you don't want to even match the dot and space, then you have to put this dot and space in this regular in the square bracket. In that case, you will get only the consonants. This is how you can even create a negative character class by as a new regular expression character. You can also use caret symbol at the start of the regular expression to indicate that the match must start or occur at the beginning of the search text. Similarly, you can put $sign at the end of the regular expression to indicate that the match string must end with the specified regular expression pattern. And also you can use both caret and the dollar together to indicate that entire string must match the regular expression pattern. Let us take up the example for the caret symbol. Here we use the caret symbol at the beginning of the regular expression. It means that the hello should be found at the beginning of the text, then only it will return a success and it returns the hello as a matched pattern. With this example, we get the match as a hello. That means it returns the hello as a matched pattern. And let's take up this second string. He said hello. This will not return a match as hello because hello is not found at the beginning of the matched text. It is found at the end, or even if it is found in between, it will not be considered as a matched pattern. Let us take up the example for $sign character. The regular expression of this form will match all the strings that end with the numeric character between 0 to 9. In this example, this will return a match because the numeric is found at the end of the matched string. And for this second example, it returns none because there is no numeric digit at the end of the string. Similarly, if you use both caret and dollar symbol together, then it matches to the actual regular expression. For example, if you use this pattern, regular expression pattern, then it matches only the numbers, not the characters other than numbers. /D represent the digit plus one or more occurrence, and the caret sign says that the pattern match should start at the beginning, that the digits should be found at the beginning, as well as digits should be found at the end. And what is that digit? That means the sequence of the numbers, digits, should be found at the beginning, as well as sequence of digits should be found at the end. That means it will match a number having more than one or more than one digits. For example, if we supply this as input, this will results in a match, and if we supply this input, and this will return none because there is no match for this written regular expression pattern. The dot character or a period character in a regular expression is also called as a wildcard character, which will match to any character except new line. Let us take up the example. Here we are going to match any character. We are using a single dot which match to the single character, any character other than new line. And if we use a FindAll, it will retrieve cat, hat, sat, etc. from this line of text. If you want to match everything and anything with the regular expression, you can use dot star. Remember, dot implies any single character other than new line, and star implies 0 or more occurrences of the preceding characters. Here is an example. Here we have created two groups. One is a group with dot star, any number of characters, 0 or more occurrences of any character. Here also 0 or more occurrences of any character. You can see this is a mandatory regular expression, a pattern, and here also mandatory regular expression pattern. And if you want to extract the group 1 and group 2, group 1, here it is AL, and this is the Swigert, this is the second the author name. This is how you can use these wildcard character along with the regular expression character class, that is star. The dot star uses a greedy mode. It means that it always tries to match the longest pattern, and to match any and all text in a non-greedy fashion, we have to use dot star followed by the question mark. Here is an example. This is the non-greedy match where we are using a question mark after dot star, and this is a greedy matching where we don't specify the question mark and the longest match will be retrieved. And in the previous one we can see only a shortest match is retrieved, as it is a non-greedy matching mechanism. Matching of new lines. We can match everything including the new line by passing re dot all as a second argument to the re dot compile. This will match everything, even including the new line. If you take up the dot star, it will match everything. That means all the characters except new line, and the output of this here is only the serve the public trust is the output of this regular expression. And if you want to match even the new line present in a line of text, then we have to use a second parameter, that is re dot all for the compile method. And with this second option we can even match all the characters with the regular expression dot star including the new line. Now you can see in the second example we have a larger matched string containing multiple new line characters. This slide shows the summary of all the irregular expression symbols we have seen so far, starting from question mark till the caret symbol to create a negative regular expression character class. Case insensitive matching. Normally regular expressions match the text with the exact casing that we specify in the regular expression. For example, if you want to match only the capital text of Robocop, then we have to specify the regular expression like this. If you want to ignore the case sensitivity, if you want to match both uppercase and lowercase letters present in a line of text or a string, then we have to make our regular expression case insensitive by passing re.ignoreCase or re.I as a second argument to the re.compile method. Here is an example. We create the case insensitive regular expression object Robocop by passing a second parameter re.I. and we can retrieve the matches which obey the pattern specified in the regular expression, irrespective of the case, that is uppercase or lowercase letters present in a given pattern. Regular expressions can not only find the text pattern but also allows us to substitute new text into the matched patterns. For that we have a sub method which is associated with the regular expression object. It takes two arguments. First is the argument is a string to replace the obtained matches, and second one is the string that we are going to supply for regular expression for pattern matching. And this sub method will return a string with the substitutions applied. It means that it gives the modified original string with the substitution applied based on the patterns found as per the regular expression. Let us take up the example. We create a regular expression object with a compile method, and we define a pattern agent space then W small letter for the word. That means at least there should be one letter here, W plus. This is a pattern that we are going to look for one or more letters, and if we get this kind of pattern, we have to substitute with the substitute text. That's what we have to specify in the sub method. Censored is actually substitute for this occurrence of the pattern, and the output of this we get is censored gave the secret document to censored, because agent space the set of letters is the pattern, and this is replaced with the censored, and here also agent Bob dot will be replaced. Bob will be replaced with the censored. Suppose if you want to repeat, if you want to put the matched text or even portion of the matched text into the substitution, this can be done by using grouping. Let us take up the example. Here we use the same pattern agent, but we have created a group here. /W is at least a group containing one letter and followed by 0 or more letter. This is the pattern, and we have created a one group, first group, followed by the number of letters. And if you want to substitute this with the matched character, there is a group, there is the first letter of the after agent. What we have to do is we have to write substitute as /1. It means that the content which is matched found in the first group, followed by a fixed character star, and the output of this is nothing but A. Agent is actually the fixed pattern to be matched, followed with capital A and other things up to this. This is the recognized pattern, and we are going to retain A. That is A 4 star told again C star, that E star, etc. This is how you can use the matched portion of the text itself as part of substitution, so that you get the contents of the original string being substituted whenever or wherever required in the newly created or substituted string. Managing the complex irregular expressions. If you have a complicated text patterns to be recognized, in that case we'll be having a lengthy irregular expression in a single line, and it is very difficult for the programmer or the programmer to read and to understand these lengthy regular expressions. To make the regular expressions readable, we have a special option in the compile method. What we have to do is we have to use the verbose mode that is enabled by passing re.verbose as a second argument to the re.compile. Let us say we have this complex irregular expression in a single line. We can split this irregular expression for the better understanding and readability by using this verbose method, verbose option. This is how we have to do is we have to do it. We have to consider this as a raw string with the triple slash. This is a multi-line string. Not slash, triple single apostrophe or double quotes, single quotes or double quotes, wherein you can specify the portions of the regular expression in a different line. First one is for the area code, second one is a separator, then first three digits and so on. And after enclosing this as a multi-line string, we have to pass the second option to the re.compile, that is re.verbose, which will ignore all these additional white spaces that are present in between the regular expression, and thus we can make the regular expression more readable and neat, so that the other programmers or learners can understand the patterns and the sub patterns that are being represented with the complex regular expressions. Combining ignore case and .all and verbose. If you want to use verbose to write comments in the complex irregular expression, and also you want to use the ignore case to ignore capitalization, we cannot supply both the things as a parameter to the compile, because compile will take only the single value for the second argument. What we have to do is we have to combine these different options with the pipe character. We can have re.ignore case pipe with re.verbose pipe with re.all, so that in this the compile context, this pipe is also considered as a bitwise OR operator, either ignore case or .all or verbose. This is the example we have here. We have used both the options, ignore case as well as re.all, and in the second example we have used the pipe with options for all the three, ignore case, .all and verbose options. This is how you can have the effect of all these things to improve the matching as well as the readability of the complex irregular expressions by writing even multi-line regular expressions with or without comments. Let us take up the programming exercises. The first program is to recognize valid phone numbers of the form. Extension is a area code followed by hyphen and 3 digits hyphen 4 digits, or 3 digits space 3 digits and 4 digits. Here this area code is optional, and you can have either hyphen in between area code and the two groups of numbers, space or hyphen. Let us write the program by first defining a suitable regular expression to recognize these patterns for phone numbers. Here is a program. We import the library regular expression, and we create the regular expression object by supplying the regular expression for the pattern to compile method, and we have to recognize the three groups or three sub patterns of telephone number. First is the area code, then first 3 digits followed by last 4 digits. And here this is a regular expression to recognize the area code 3 digits, or we have digits within the parenthesis, 3 digits within the parenthesis, and all these things are optional. This area code is optional. You can see parenthesis followed by the question mark, 0 or 1 time appearance of this area code, and two ways of representing area code. One is with just 3 digits, and second option is to represent 3 digits enclosed within parenthesis. Then we have a space or hyphen. You can see here slashes for space and hyphen. This is a character class we have created. Then again 3 digits followed by space or the hyphen, and this is the last 4 digits, and we use the option verbose since we use the comments as well as new lines in between the regular expression. And this is a sample string that we are going to pass to extract all these numbers, and this FindAll will return the list of all these patterns. Almost 4 patterns are being identified, this one, second, and third one. Okay. And this will not be recognized because it doesn't support the doesn't obey the pattern of a telephone number. This is how we can recognize and extract the telephone numbers of different forms, with hyphens, with area code, and even without area code. Now let us take up the second program to recognize valid email addresses. The addresses with the email ID containing dot in between digits and letters, then even domain name with the subdomains. And we know that @ symbol is found at the email address. First let us write the irregular expression to recognize such email address patterns. Here is the regular expression. This is to recognize the username with all the letters. What we have done here is first sub pattern. We have created a character class. Okay, you can see here plus symbol. One of these character will appear at least once and more than one or more number of times. I have A to Z, capital A to Z, 0 to 9, even dot in between, then underscore, even percent sign, plus, minus, etc. Then we have a mandatory @ symbol, then followed by again domain name with dot. You can see the regular expression character plus, then finally the last .com, okay, or it is for the .in, .com, .edu, and so on. This is the last segment, and here this character is not just a plus, maximum 2 to 4 characters, like in up to com, etc. And here also we mandatory write the pattern, that is a dot is essential here at the end. And with this pattern we can recognize these email addresses like this. Third program to extract the floating point number, something like this, from the line of text which starts from X, capital X hyphen. How do we write the regular expression? We have to first match X hyphen. That means we have to see that X hyphen is found at the beginning of the text. Then any number of characters Then we have to check for colon, mandatory colon, whether colon is present, and then we have to extract the number 0.8 or whatever the number, floating point number up till this space. Here is a regular expression. We use a caret symbol here to match x hyphen at the beginning of the line, then slash s star means anything other than space, 0 or more, that will match up to this, then mandatory matching of a colon. Then we need to extract this number, that's why we have enclosed the parenthesis to create the group, okay, and we have to use this subregular expression 0 to 9 one or more times followed by a dot, and this regular expression will extract the floating point number from the given line of text which starts from x hyphen. Now let us write a program to extract the number, something of like this, from the line of text with a word URL colon. First we have to write the regular expression to match at the beginning of the text URL colon. You can see here caret symbol URL colon, and we have to extract the match the digits at the end. You can see here 0 to 9 plus dollar. Dollar is to match the set of digits at the end. Then after this colon we can have any number of characters, DotStar, then mandatory REV equal sign. You can see here with this DotStar we can match up to here, then mandatory REV equal, then we need to extract this number 0 to 9 digits plus one or more occurrence, and we have to see to it that this number is found at the end and no more characters after this number. That's why we use the we use the dollar within the parenthesis. This is how you can extract this number which is found at in the end of the URL. Let us write a program to extract the hour of the day from the line of text which starts from the word from, email address, day and date, followed by the hour, minute, second and the year. How do we write the regular expression? We have to use the caret symbol to match the beginning of the text which starts from the word from. Then we have to look for a digit, 1 or 2 digits, there is a date followed by a space and the hour colon. This we have to extract after matching this hour colon. Here is a program. We match the beginning of the line of text from, then any number of characters, DotStar, then 1 or 2 digits for this date, followed by 1 space, then first digit and the second digit, then mandatory a colon, and we have to extract only these 2 digits, hour, 0, 9 or 11, 12, 23, whatever the hour of the day. This is the portion of grouping which extracts the hour of the day. As a last program, let us take up the other number recognition. We know that other number is of 12 digits, and we normally find 2 spaces between the 4-digit groups of numbers. First we have a 4-digit number, then one space, then again 4-digit number, space, followed by last 4-digit number. This is what the common format of Aadhaar number. Let us try to recognize the Aadhaar number with a suitable regular expression. Here is a very simple regular expression. We match first 4 digits mandatory, then one space, then again next 4 digits, space, and last 4 digits. Instead of this character class space, you can have a /s. /s is also valid. And also we will check for the length of this string, the maximum length of this string, not maximum, actual length of this Aadhaar number string is of 14 characters. That's 12 digits plus 2 white spaces between the groups of digits. And if there's a change in the number of characters in that Aadhaar number, then definitely it's an invalid Aadhaar number, and otherwise we retrieve all these, we'll recognize the number and that number, saying it is a valid Aadhaar number. Let us summarize the discussion. We used FindAll method to retrieve all the match patterns. We applied the sub method to substitute a given text into the matched pattern, and we use the different options of compile method to improve the readability of a regular expression. And finally, we created character classes and executed few programs to find the interesting patterns